In this video, we will discuss about unbalanced transportation problem using northwest corner method and Vogel's approximation method. We know that there are two types of transportation problem: balanced transportation problem and unbalanced transportation problem. If the demand and supply are equal, it is called balanced transportation problem. Otherwise, it is unbalanced transportation problem. Consider this example. Here, the supply is 15 and the demand is also 15. So, if the demand and the supply is equal, then this problem is balanced transportation problem. But in this example, here supply is 10 and the demand is 15. Here the supply is not equal to demand. Then we can call this type of problem is unbalanced transportation problem. Transportation problem mainly consists of two phases. First one is finding the initial basic feasible solution. The second one is optimization of basic feasible solution. To find the initial basic feasible solution, there are three different methods. First one is northwest corner method, the second one is least cost method, and the third one is Vogel approximation method or penalty method. To optimize basic feasible solution, there are mainly two methods. First one is modified distribution or MODI method, and the second one is stepping stone method. Now we are going to see unbalanced transportation problem using northwest corner method. Consider this transportation problem to determine the initial basic feasible solution. Check whether the given transportation problem shown in table is a balanced one. If not, convert the unbalanced problem into a balanced transportation problem. So add the supply, we will get 490. Here the total demand is 540. That is, here in this problem, the total supply is not equal to total demand. Hence, the given problem is an unbalanced transportation problem. Here, the total demand is 540 and total supply is 490. Since total demand is greater than the total supply, we introduce a dummy row with its supply as 540 minus 490 equal to 50. And we take all the cost elements of this row as 0. Thus, the transportation problem becomes like this. So, now the demand and the supply are equal. Now, our unbalanced transportation problem has been converted into balanced transportation problem. The unit costs of transportation of dummy destinations are assigned as 0. The modified problem is shown in table, which has been converted into a balanced transportation problem. And we take all the cost elements of this row as 0. Now we are going to solve the problem by northwest corner method. First of all, select the northwest corner of this table. Which one is the northwest corner? Here it is the northwest corner cell. Compare the demand and the supply. Here, which one is the minimum value? 150 is the minimum value. We can allocate 150 here. Then we can cut this one. We will get 0. And also we can cut this and we will get 50. We can delete this column which has no value to demand. So we can cut this Again, check for northwest corner. Here, the cell is the northwest corner and we can check it for allocation. Here 40 demand is available and also here 50 supplies are there. Then which one is the minimum value? 40 is the minimum value, so we can allocate 40 here. Then we can subtract 40 from here. Here we will get 0 and we can subtract 40 from here, we will get 10. So we can eliminate this entire column because no value here to apply. Again, here 28 is the northwest corner, so we can check it for allocation. Here 10 supplies are here and 180 demands are here, so the minimum of these two is 10, so we can allocate 10 here and we can subtract 10 from here, we will get 0 and we can subtract 10 from here, we will get 170. So here nothing to supply, so we can delete this entire row. Again, which one is the northwest corner? Here this cell is the northwest corner, so here it has 170 and here it has 180 supplies are available, so we can allocate 170 here. Then we can subtract 170 from here, we will get 0 and we can subtract 170 from here, we will get 10. Then we can delete this entire column. Again, only one column is remaining. Here this one is the northwest corner, so we can allocate the value here. Here 10 is here and here 170 is here, so minimum of these two is 10, so this 10 will get cancelled, we will get 0 and here 170 we can subtract 10 from here, we will get 160. Again, this one is the northwest corner. Here 160 is available here and 110 is here, so minimum of these two is 110 and this 110 will get cancelled and we will get 0 here, and also we can subtract 110 from here, we will get 50. The only remaining cell is this one. Here we got 50 50, that is now the problem is balanced problem, so here the demand and supply are again equal, so we can allocate 50 here and it will get cancelled, it will get 0 and here also it will get cancelled, we will get 0. Then to find the total transportation cost, we can multiply with 150 into 20 and 40 into 25 and 10 into 28 and 170 into 32, 10 into 41, 110 into 32 and finally 50 into 0, that is 0. Transportation cost equal to 150 into 20 plus 10 into 25 plus 10 into 28 plus 170 into 32 plus 10 into 41 plus 110 into 32 plus 50 into 0, which is equal to 13,650. So the total transportation cost is rupees 13,650. Next we will see unbalanced transportation problem by Vogel's approximation method. First, we need to find out the total supply and the total demand. Here we have the supply 175, 125, 400. That means it is 700. And here 200 plus 150 plus 250. That is the total demand is 600. So here the demand and supply are not equal. So we need to add a dummy column here. So we add a dummy demand constraint with 0 unit cost and with allocation 100. 0, 0, 0, and here 700 minus 600 is equal to 100. So we can write 100 here. Now the total demand is 700 and the total supply is also 700. So now this transportation problem is ready to find out the basic feasible solution. Now we need to calculate penalties for each row and each column by taking the difference between the smallest cost and next highest cost available in that row or column. If there are two smallest costs, then the penalty is 0. Look at the first row and select the least cost. Which one is the least cost? 0 is the least cost. Then which one is the next least value? 10. So we have to find out the difference of 10 and 0. What is the value? 10. In the same way, find out the difference of each and every row and column. Look at the second row. What is the least value? 0 here. Which is the second least value? 15. So the difference of 15 and 0? 15. Consider the third row. 0 is the least value. The next least value is 20. So the difference is 20. Again consider this first column. Which one is the least value? 20. Next least is 25. So the difference 5. Here 40 and 45. So difference 5. Here which one is the least value? 10 is the least value. The next least value is 15. So the difference is 5. Here 0. Now we got the row difference and the column difference. The second step is select the maximum value among this row difference and from this column difference. Here look at this row difference and the column difference. Which one is the maximum value here? 20 is the maximum value. After finding the maximum value, identify the cell for allocation which has least cost in that row or the particular column. So which one is the least cost in this particular row? 0 is the least cost. So we can select this cell for allocation. Now we can allocate the least value by comparing the demand and the supply. Here which one is the lesser value? Here 100 and 400 is here. So 100 is the least value among these two values. So we can allocate 100 here. After allocating 100, here we will get 0. And here we have 300. So this particular column will get cancelled. After deleting this particular column, again we need to do the same procedure. consider the remaining unallocated cells. Here consider the first row, which is the minimum value here. 10 is the minimum value, and the next least value is 25. So the difference between 25 and 10 is 15. Again consider the second row. Here 15 is the least value. The second least value is 30. So the difference between 30 and 15 is 50. Again consider the third row. The least value is 20 and the next least value is 40. So the difference between 20 and 40 is 20. Again consider this first column. Here the difference of two least values are 5, and here also we will get the difference is 5, and here 10 and 15, so the difference is 5. Now choose the highest value among these penalties. So here we will get 20 as the highest value. So choose this corresponding row for allocation. Here again we have to find out which one is the minimum value. Here which is the least cost cell? This one is the least cost cell. So we can select this particular cell for allocation. Then check the demand and the supply of this particular row. Here the demand is 200 and the supply is 300. So minimum of these two is 200. So we can allocate 200 here. So it will get cancelled and we will get 0. Again from 300 we can subtract 200, so we will get 100. So we can eliminate this entire column. Again find out the penalties of these 3 rows and 2 columns. Here 45 and 10. Then what will be the difference? 35. Here the least value is 15 and the second least value is 65. So the difference is 50. Here 40 is the least value and 55 is the next least value. So the difference is 15. And here we will get 40 and 45. So 5. And 10 is the least value. The next least value is 15. So we will get 5. So among these, which one is the highest value? 50 is the highest value. So we can consider this particular row. 15 is this cell is the least cost cell. So we can select this particular cell for allocation and check for supply and the demand. Here supply is 125 and the demand is 250. Which one is the minimum? 125. So we can allocate 125 here. This will get cancelled and we will get 0, and we can subtract 125 from here, then we will get 125. So we can eliminate this entire row because here we get 0. Then again 2 rows and 2 columns remaining. Here again we can consider the first row. Here only 2 elements are here, so we can simply take the difference of these two. We will get 35, and here 40 and 55, the difference is 15, and here 40 and 45 will get 5. Here 10 and 55, so the difference is 45. So which one is the highest value here? 45 is the highest value here. So we can select this particular, consider this particular column. And which one is the lowest value here? 10 is the lowest value. So we can consider this cell for allocation. Then again check it for supply and demand. Here the supply is 175 and the demand is 125. So the minimum of these two is 125. So we can allocate 125 here. So here it will get cancelled. So and here we can subtract 125 from 175, we will get 50. Here we got 0, then we can eliminate this entire column. Again consider the remaining unallocated cell. Here only one column is here, so we can select the minimum of these two. Here 40 is the minimum, so we can check it for demand and supply. Here 150 demand and 100 supply is there, so we can allocate minimum of these two. So we can allocate 100 here, then here we will get 0, and here we will get 50. So here we got 0, so we can eliminate this entire row. So the remaining only cell is 45. So we can check for demand and supply. Here demand is 50 and the supply is also 50 because it is balanced problem. So we can allocate 50 here. After allocating all these things now, just multiply the allocated cell values in order to find out the total transportation cost. That is 50 into 45, 125 into 10, plus 175 into 50, plus 125 into 15, plus 200 into 20, plus 100 into 40, plus 100 into 0. So total transportation cost equal to 50 into 45 plus 125 into 10 plus 125 into 15 plus 200 into 20 plus 100 into 40 plus 100 into 0, which is equal to 13,375 rupees. According to the Vogel's approximation method, the total cost is 13,375 rupees. Thank you.